students, here's a problem that looks a lot harder than it is. Please note at the top my little hint. Once you know the rate determining step, that is the slow step in a mechanism, then the coefficients in the differential rate law correspond to the coefficients in that slow step. Prior to this, before we talked about reaction mechanisms, you needed empirical data, that is a data table, in order to find the differential rate law. But if you're proposing a mechanism and you know the coefficients in the slow step for the reactants, you've got it. You don't even need the data table. So here in this proposed mechanism, we have a slow step where they kind of wrote it funny. I would have just written 2NO2, but they separated those out. It's NO2, there's two of them, and those are the only reactants in the slow step. And so the rate law, differential rate law that corresponds to that is rate equals K times NO2 raised to the second power. Next, they ask us for an overall balanced equation. They just want to see, can you cross out catalysts and reaction intermediates? And that's not, if we add these two steps in a mechanism together, looking for things to cross out, first of all, I see that NO3 is produced and then consumed, and NO2, at least one of the NO2 molecules, is reproduced at the end. So if we add all of that up, on the reactant side we have NO2 and carbon monoxide, CO, and on the right side nitrogen monoxide and carbon dioxide. And they want us to balance this, and it looks like it's already balanced. So note one little thing, formatting issue with WebAssign. They want you to put a 1 if the coefficient is a 1. And they already wrote CO as one of the reactants. So you just put a 1 in the box in front, and a 1 in front of nitrogen monoxide, and then a 1 in front of carbon dioxide in terms of WebAssign formatting.